want to introduce Simone Amber and Nader Shatirian of the School of Fab Lab. Thank you so much for coming to give this presentation and talk to us about Fab Labs.
Thank you. Thank you very much for the opportunity. Before we get started, I want to just thank everybody to be present today. And based on, I don't know who is the other person who just joined, but based on the introductions, we might, decide to move a little bit our presentation differently. Because, I don't know if you want to have an experiential learning about 3D printing, or more focus our conversation about maybe show you quickly what the workshop could look like in fast forward, and then have time for conversation about how do you integrate such skills into the different environments that, or areas of interest of each one of you. So maybe we can get started a little, and then please feel free to ask questions, whether in the chat or just live. We're a small group, so we can really use this hour to the, to the best way. Okay, very quickly about me. I met Sarah when we were working 20 years ago with the consortium created by Peter Senge from MIT on sustainability. And I was a senior executive at Schlumberger then, and created at the time, the first in 1993, actually had the idea through a meeting at the MIT Media Lab with Seymour Papert, who was a co-creator of the Media Lab and also a pioneer in artificial intelligence, created the first corporate social responsibility program and about STEM education, supporting schools in developing countries, in poor communities. So we've supported 1,000 schools through the technology of MIT, making it possible, giving them computer labs, internet access, and professional development for teachers around mostly, it was all hands-on, but mostly around two issues that were close to my heart and still close to my heart, which are water, climate change, and empowering women and girls. So this being said, here we are offering how to adopt cutting-edge technology with ease. And I think this is probably the most important word, is we are part of the Fab Lab network, as we've been working, with Neil Gershenfeld, who is the creator of the Fab Lab at MIT. I was actually served on his board of the Fab Foundation. And we realized that the concepts were very advanced, and we wanted to do something that could be more easily available to I would say, the more average person, in terms of who's not necessarily an engineer or technology person. And we decided also to focus on communities and schools by focusing on professional development of teachers, because if they are not comfortable, then there's no point in having all these machines and etc. And so our focus has been about bring this technology with ease, and in mind, what we had in mind is really preparing people, whether they're young or adults, to the skills they're going to need now with a major shift in all the jobs due to technology. So through this collaboration with Neil Gershenfeld, we realized that we needed to prepare to organize a platform around the technologies that are here. I might go fast because of the group who is here now. Digital design in 2 dimensions and 3 dimensions. Digital fabrication in 2 dimensions and 3 dimensions. The drone flight and programming, because we realized that this is a very fun way by flying drone and then having it do certain things that actually the learners then are really interested in programming. Design thinking, of course, prototyping. And we developed the the three other subjects that are not normally part of a Fab Lab, which are virtual reality apps, augmented reality apps, and artificial intelligence module to explain what it is. And finally, of course, which is part of the Fab Labs, electronics and robotics. And today what we had in mind is we designed the session for someone who might be interested in understanding initiation about 3D design and fabrication. Just very quickly, the world of Fab Lab has grown tremendously. And today there are 1,600 Fab Labs in 108 countries. And it is truly global and network that supports each other, but also addressing local problems and, you know, sharing with each other. So what we had planned today is really for Nader to go into the additive, to explain what Fab Lab is, which I did quickly, explain the additive manufacturing, and then have a 3D design and fabrication and hands-on activity to show how we break things in small pieces to make it easy. And that's what we've been using for professional development for teachers, fab managers, as well as for adults. And then talk about next steps. And hopefully Mickey will stop us, 10 minutes before the end for Q&A, unless we have Q&A as we go, which is totally also very good. So to you, Nader. Oh, do you want me to do this one? Okay, I can do it. So basically, we've been focusing on project-based learning, and which includes, as we spoke about, a Fab Lab makerspace, developing career skills, STEM or STEAM, in particular in the academic, school context. We're using a constructionism method, which is what Professor Seymour Papert that I mentioned. It was the main work of his life, which is you learn by doing. And of course, this can also be linked to career and technical education. Nader, I'll leave it to you.
Sure. Thank you. My name is Nader Shatirian. I got introduced to the concept of Fab Lab in 2007, and since then I've been really advocate and trying to figure out a way, working with Neil and other group in Fab Lab, how we can bring concept of Fab Lab and new technology and trends to schools and to educators and to people that are not aware of it, and how we can simplify it. My background is I graduated as a mechanical engineer. I went to aerospace, and then I switched back in '95 to computer science. I worked in Silicon Valley for 15 years. And after right around when I met Neil, I was trying to completely change my life and my career. And this was really a moment for me that I realized what machines I used to work in manufacturing was $500,000. We used to call it a stereolithography instead of 3D printer. It would take weeks of work, sometimes months, and the part will cost a couple of $1,000. And when I met Neil, I saw the MakerBot printer that was $1,000, and it was making parts for $1, and it was better than what I used to be able to make on this old machine. So I realized there is exponential change, and as a result, we start building Fab Lab, working with a network. But what was stunning that there wasn't enough people interested in technology, science, engineering, graduating, and we realized that the biggest challenge for us is to go to lower education, K through 12, and figure out how we can inspire young generation to get interested in these concepts. And we created this model mainly for a school. We called it the School Fab Lab. It's basically a simple model of breaking the Fab Lab to 10 stations. And as Simone mentioned, we added new station to the lab, or we call it the micro lab within the environment. And we made it modular. So virtual reality and augmented reality and artificial intelligence was part of, addition to it, the rest of it is part of a standard Fab Lab, which is really important in manufacturing. And we made it in a way that we have an introduction to each of these concepts. The introductions are usually a couple of workshops, and then from there you can explore how you move to the next level, depending if it's career or is educational related to STEM. Today, what we thought is the best is to just take you through one of our models about 3D printing. We usually use this workshop as introducing everyone to the concept of a 3D printing, 3D design, and 3D manufacturing. And part of it is designed to be done in 45 minutes. We usually realize that unlike Fab Lab, that is an open space and individual come in and explore and learn and collaborate, and they learn from each other. In a school setting or in a structure setting, we have a time limit, and we had to fit things into that time limit. In reality, these workshops usually take about an hour and a half. We talk about the concept, we show maybe a short video, and then after that, we try to apply that concept into an activity. And in recent year, we have focused really heavily on virtual labs, like virtual machines that can really demonstrate how the real machine works. And the rest of the work can be done through what we're going to go through today as online video conferencing like Zoom. Before I jump into the workshop, and usually part of our series of workshop is we talk about Industrial Revolution, and the most important, I'm not going to today, is really not about Industrial Revolution, but the point about Industrial Revolution is that Industrial Revolution is moving forward. We are currently at the fourth Industrial Revolution in some kind of analogy, and as a part of that is what we try to demonstrate, that each of these Industrial Revolution, as we can see, the timeline have become shorter and the complexity have gone up. So what you see here in the color and in the right side is the complexity chart, and then you can also see each of the timeline as it's scaled to what they are. And what we are really experiencing is this exponential growth in technology and new services that provides. And it's the first time, I think, in human history we've seen such a massive explosion into software and machine, and also reduction of the cost. So by this, we can really look at the 3D printing as a concept that it's really allows that manufacturing to become individualized, and you can do it at home. And our goal been that to make this concept easy, turn each of these technology into something that it's comfortable for average person to use. We treat 3D printing as a printer, like a normal printer that you might have at home for many years, and you're comfortable with it. We just try to conceptualize that in a 3D printing, we actually printing the real object. It's a type of additive manufacturing, and it's done in layer by layer. And part of understanding about it is how it's working, what are the components in it, why we have 3 axes in order to make an object, and we define those axes as X and Y. And basically, the heating head or the nozzle is where the material is heated. It actually works like a hot glue gun, which is controlled numerically by a program. And the program basically breaks the 3D printing object into the layer and prints it. I'm going to play a video for you because it's really very quickly in 2 minutes, it would describe it. I hope you can hear the sound of this video and it's clear. And we probably after this meeting will send you a link to most of these videos so you can also watch it and later on and can use it if you need to use it in different aspects. Allow me to play this for a second. Let me just.
Weird.
Well, I'm not sure why the sound doesn't come through. It's probably the way I'm using the mic, but we can skip this and I can send you the link.
Okay.
And basically, the concept of 3D printing is taking a 3D model file and going through a program, which is slice that program and create something as we call machine code. And then the 3D printing has all the code to move the nozzle around and layer by layer build this object. So the concept is that we can use all kinds of different material to go through the same process. So the 3D printer doesn't have to be a simple plastic. It can be metal, it can be all kinds of different kind of alloys, it can be titanium. So that allows us a whole new way of building part and also a complex part. There is 3D printing in variety of aspects of industry that is being explored, including bioprinting, which are trying to achieve printing skins and organs and so on and so forth. In 3D printing, we have three key important concepts. One is a slice and the slicing software that we use. And then we get to a point of a support because you're using the hot material to build something. If you have a ridge and you're trying to print that, you need to put some support under it in order that the hot plastic or hard material is supported. Otherwise, you will have a decay into your part. And then the other concept is the infill, because 3D printer usually use this algorithm to create the shell of the object. And what you put inside of it, it determines how heavy it is, how long it takes to build, and how strong it will become. So the infill is usually done in a percentage, and that's the key elements of how strong this will be. Now, when we start with the 3D printing, we don't need to know everything and we don't need to have a knowledge inside of it because we don't have the experience. So we go through a process of finding files that we like to print and then leveraging the community knowledge, which usually tell us what is the infill and what is support. And I'm going to walk you through in our hands-on activity that how do you look and how do you find these kind of information when you want to print something. In manufacturing and in engineering, the 3D printing has this aspect that allows you to make something very quickly, even if it's very complex. And that is very important because you can see from a static, you can see from a component assembly, you can see how you can collaborate with other people in your team, or even getting it into the market early on and testing with some customers to see how your product will be presented and get feedback. So these concepts at the very low cost that the 3D printing offered in the manufacturing allows an explosion in design and manufacturing, and you can do it in a very small scale. In the past, if we needed something complex, we had to create the mold, we had to go and produce it in a very large volume to get the cost down. But with a normal 3D printing, we can actually build that part one at a time, very unique and customized. It is slow, and in some cases, it's not the small home or affordable 3D printer is not fitted for a spare part or usage in a real world, but it's actually to create that concept and then use it as a mold or use it as a way to progress your design or your activity. It's really useful. And now with all these online services for 3D printing, you can take the same file, print it in plastic, and then turn it back and print it in different alloy and use it.
May I just add one thing on that? We have created a Fab Lab as a community center in another island in Corsica. And we've done it pro bono because we spent some time there, and we created a public-private partnership. We made it happen. And it's very useful, I think, for an island, because you can also make things that fit exactly specific needs you have, or sometimes you don't, get delivery, etc. So like Nadia was saying, like old machines, old boats, needed parts that are not made anymore, one can make them like that, and either print it with the 3D printer you have, or then send the part once it was completely designed to be printed somewhere else. But for an island, I think it's very important in order to be self-sufficient, to be able to make specific objects for specific needs on the spot.
Cool. The most important part in 3D printing is, how do I make my model? And how do I take that model and test it? Which a normal 3D printer, if you have a model, you can test it very easily, and you would have it in plastic. And then from there is your choice, what material or strength you want, how do you want that part to be made, in what kind of a material. And then you can use the online services to make it. But in order to get your model, there is a multi-millions of files that are shared freely online. And so downloading a 3D file and knowing where to go to find a model is important, and how to get to the best model that we're going to cover today in our hands-on activity. And then the other solution is to just scan your part and get the model of it, and then work from there on, or use like Tinkercad or AutoCAD 360, or a variety of software that are available, either free or not free, to design your own files and models. And then when you have your models, then from there, it's very easy to get to the process of 3D printing. So as we mentioned, the material varies. Food is coming into, like, printing chocolate. Ceramic is another part that is becoming very, very exciting field of 3D printing, and different alloys that are existing in the field. There is a video, I'm not going to play it, but this is a company in LA that are printing rocket booster and tanks, and they just this year they had the test into 2020, and they're actually can reduce the manufacturing of the rocket nozzles and the tank in a very short time and at very low cost. And they have designed their own 3D printing machines. So all of those are possible because the footprint of these new manufacturings are very small, and the environmental requirement for them are very, very adaptive to almost anywhere. They're not like an old polluter of manufacturing of the past. So by this, I'm just going to basically stop, and if there's any question, we can answer, and then we're very quickly going to go through the hands-on activity. And usually these hands-on activity have the basic requirement that you should have certain software already downloaded. You should have a PC or Mac. Chromebook usually doesn't work for these type of software. Install, and then we can very quickly go together through these activity and make sure that you're comfortable to download your first model, simulate it in the software, and then send it for print or print it on your machine. I'm pausing for a second. If there's a question, we can address it now, or I'm just going to go through the next phase. The most used and elaborate website for finding model is Thingiverse, and it's basically now called MakerBot Thingiverse. And you basically can go in there and find anything you want. You just basically search and you look for a key term. So as the activity, what we do is we first make sure you can, because you have to register before you can save things and find things. So we recommend you to go to the website and register. And part of this is there is a link for the website. And when you go in there, you register yourself with your email address. And then in this exercise, we're basically looking for respirator. We're going to print and download our model and also understand how to find the right model for your need. Now, when you search for respirator on Thingiverse, there is an option that you want to really focus on, and that's what we call the how many people make that file by themselves. And that is important because the files that are made many times usually are discussed in a discussion, and there's a lot of information available on that file and that folder, which helps you to find the right thing quickly and make sure that this is the one that has the least issue in printing. And that really is a fast way to go forward. So we do a little search on the Thingiverse, and we look for the make, and as we do, we get the first one that is there. And this is basically a respirator that has enclosed the filter and is using the makeup pad as the filter, which is very convenient. And the cap that goes on actually locks the makeup pad, and it also prevents from anything being spill on. If somebody cough on you, it doesn't get to your filter because the filter is covered by the cap. Now, right there, you will see that the most important part for your 3D printing is the percentage of infield and do I need a support or I don't need a support. And if you need support, meaning it's going to take longer, you're going to put some material into your object, and later on you need to scrub or remove them, and sometimes it becomes a little bit difficult to do that. So when the file doesn't have a no support, that's great. That means it's designed a way that is easy to be produced. And when there is zero infield, it means that it really going to save cost and it's going to actually be good. Now, the point is that you need to really read the summary of the file after you find, which one it is. And as I mentioned, the number of the make is important because that shows that file has actually been active in the community. And the number of a comment is important. And if we really look at all the masks that are 3D printed, they all come from Montana Clinic, and they're originally come from there. And actually, you can, from this section, you can go to the original file and also see what the original file is. There usually you have a lot of video and you have a lot of file. Now, when you get to the files, you can download all of them and it comes in a zip file, or you can just download individual and then use it into your software. Now, you need a software. So this is about zip part. We usually, if people are not familiar with zip and they download it, we just walk them through that. And then we get to the MakerBot print software. The reason I'm using this is in our school, there is a concept of 3D printer that are more complex to work with, and there are a concept of 3D printer that are really simple to work with. MakerBot is trying to present these models as something that doesn't need much of a tweaking. If you have a MakerBot printer and you go through the software, usually the product comes out the way you see it in a simulation. And the software is for free. You can download it and you can simulate the 3D printer very quickly and see how it is. So you go to the website, you download the software, and the rest of these are basically talking about the component of the software that we go in, how to create a project, how to add the project into your plate, and then you can also directly, when you register on Thinkiverse, you can create a portfolio and save what you like, and you can access that and print it directly from there. You then also need to know your printer. For example, of this case, we are using Replicator Plus as your printer, and you basically set your printer because every printer is different from the way we create that G-code that goes into it. Sometimes your printer have different extruder. These are the heating head that you need. So you have to select the right one. And then, as we discussed, is what is the support. Now, in the MakerBot software, your print mode is defined by, does it have a draft? Is it have full field or minimum field? And if you click on these dots, you will see it, and you can select with it and select what you need. We can go into detail of it. Also, you need to understand about how to orient your part in the 3D printer, and these would allow you to reorient it. There is also a concept of a scaling. So if your mask need to be large or small, you can scale it. You can scale it based on millimeter or based on percentage of a file you download. It's important to check the size of your file, and at the end of it, you can process it. And this is what really we use the MakerBot software, because it allows you to see how long it will take, how many grams it's going to be using, and you have a simulation module on the left side that allows you to go through it. Usually, we take these a slide and we follow up with a hands-on activity. So in a parallel, I will go and download, find the files, and go through the whole process of simulating it and getting the file ready for the printer. And you then can move on to exporting your file. What you're exporting is you're taking that 3D model and converting it to the code for that specific machine. And this could be done on a variety of software with variety of machine. This is just a fast way to go through them and understand how it works. You can search 3D online printing, and you also can find rating, different websites rate them. And basically what you do, you take your model and you now upload it to their website, and you get a pricing and timeline of when it can get done. And pretty much this is it. Now, if we need to do that, I can go through the hands-on activity and show you how we go and we find the model, how we bring it in, and how we get it ready for print. If not, we stop here and we discuss about what's next.
Thank you, Nader. And I want to say, based on the participants, we have a very wide range of competencies, because we have people like Sam who, do or use the 3D printers. We have people like Sarah who never used the 3D printer. So sorry, we had to we're probably frustrating everybody because it's either too detailed or not detailed enough. But we hope that this shows our approach of simplifying complexity. So there's
a lot of comments. We can go through them or we can talk about them.
Yes, and so it's simplifying complexities so that people are not afraid, whether they're teachers, individuals, to actually embrace new technology and grow with it, and for new jobs. And this is one example of the different other subjects that are on here on the next steps that are, just want to mention that all these workshops can be done virtually, which in this time and age is important. And then of course, if you have we already have some machines obviously on the island, or if another makerspace Fab Lab is created, then people can actually then go and make the object itself. So it has that ability.
Couple of questions that are here is we understand that there are ways to make filament. And there are a variety of projects. So on the Fab Lab network, there is a whole projects of other people have gone through this process, and it's easy to find them and connect to them and figure out a way that we can share that experience back and forth. The biggest challenge with reusing plastic is that when you're using plastic and you make filament, the filament head, the nozzle, it's very sensitive to external object, either from a wear and tear or from clogging. So to keep this process clean and create the filament that is recyclable, but it's useful, it's a bit complicated. But as far as the machine and setting it up, it's not a big investment, and there's a lot of experience in the network we can leverage on. Now we can stop and start discussion. This way we can actually talk about these questions.
Please unmute yourselves.
I'll go first just because I may have to duck out early. I've got my 1- and 4-year-old to myself today as my wife's off island. So we really, and one thing that's been really interesting for me is our 3D printing capabilities, and my own experience with 3D printing was really minimal up until about March of this year, when we started making face shields for the islands, and then also St. Joseph's and Bellingham. So I had a very steep learning curve very quickly. But the one nice part is it does seem like a silver lining to everything that's gone on is, I think, part of the PPE shortage and the fact that you had maker spaces around the country stepping in to fill that gap has really shown a pretty strong light on the 21st century skills needed to do this kind of work, and also the potential for the 3D printers. I mean, when they first came out, I remember people talking about how everyone was going to have a 3D printer in their home and be making their own replacement parts. And I don't think that reality has really come to pass, but I do think that in the latest, maybe the last 6 months, I think 3D printing and digital design, fabrication, and prototyping has really gotten people's attention and maybe stepped forward into the national consciousness, which is exciting, and something that's actually good timing, since my role here, I've really only stepped into the STEM building the last 2 years, and I've been working really hard to try to increase our community presence. And that's why when Mickey sent me this note and I saw Sarah's email, I was really excited, just because that's been one of my goals in the last 2 years, is try to figure out how to turn the STEM building into more than just our classroom. We've got a lot of cool stuff here. I've got laser cutters, I've got CNC routers, I've got all the stuff for student projects, but I do think there's way more potential for this building than just student use. And I know we've worked with the EDC a little bit with some afternoon classes, but the idea of a community makerspace, Fab Lab type thing is something I'm extremely interested in. So whatever the next steps might be, just count me in and know that this space would be readily available in whatever way I could make it available for that goal.
Fantastic.
Damn, I'm so excited to hear that. I previously worked with Derek, combining our fields of expertise, because that's what I'm finding is that from my work with Fab Lab in San Diego, like seeing what an MIT Fab Lab actually was in its original conception, and then looking at what are the emergent needs in this environment, it really seems like little hubs of expertise that can accommodate like power and space and expertise are needed. And now that we have a lot more Zoom mycelial web interconnections between islands, I think we could do that better. What I find consistently is that we need expertise cross islands. So like, for instance, our 3D printer is still kind of futzy. And unless you have somebody who's got a little bit more expertise, you can be on all kinds of forums and wait for that. But it would be great, Sam, to have some inter-island. And Derek and I were even talking a few years ago about like floating maker spaces. So like on the ferry where kids could come together and do the inter-island ferry and float around in a loop and like do an activity there. And of course, it depends on connectivity for a lot of it. But that was an interesting exploration. And I think like having each place have its competencies, like our remake lab, we've realized we just need to scale up. So somebody, Marcy, you talked about the fun house over on Orcas. So some folks from Orcas came over, did our remake lab with us, and decided that obviously we need to scale up. And so they bought a commercial extruder and a commercial shredder. But unfortunately, ORS, which is their trash place, doesn't have that kind of power capability. So that was the main problem. They just didn't have 3-phase power. So then all those machines got donated to the Funhouse, which is a youth space. And I'm not sure if they're currently in use, because again, without the network of connections of people who are technically proficient, sometimes you can have a really fancy machine and not be able to use it, which I think Kristen Ryan at our school and I have encountered, because I bought a 3D printer, or I helped the school get a 3D printer 4 years ago, and I couldn't get a teacher to champion it. And because they are futzy still, even now, they're not just off the shelf print. You still have a lot of things you have to negotiate in order to get a viable, satisfying print, and a lot of things can go wrong. What we've missed, I think, is this like interrelated hub of experts.
One thing I wanted to interject, it'd be really cool to keep conversations about building a Fab Lab going among the group after this is over. And at the EDC, we created the Knowledge Worker Network, which is just a sort of informal group. And part of that, we have a Slack group if people wanted to use that as sort of a platform for building these discussions. That might be a nice platform for doing that, for continuing these.
I just wanted to add one point about 3D printer. In most Fab Labs, you don't see a MakerBot printer, you see Ultimaker or various other printers. And they're sort of like, is a difference between a Ferrari and a Toyota. Toyota, you're getting and it goes somewhere every day. Ferrari, you have to tune it all the time. It does very well performance, but it's not reliable for everyday use. And the reason we went with a MakerBot in most of our labs at the school is because you get what you see and you get it all the time without any problems. And you get it over and over. And they have finally, after the last release of Replicator Plus, they solved those issues that if you use their filament and if you use their software, there is no way you're not going to get on your print machine what you didn't, you wanted. So that is very important. And also, I think some of the machine that you have is not being used is really because, as you mentioned, there's no champion for it. And it is important to empower either teachers or community members to feel empowered to use those machines. And our goal, especially at the school, has been to empower the teachers to become the champion. And then we know that the whole school then will start moving. Otherwise, you buy the machine and it ends up in closet somewhere in a year or so.
Yeah, I wanted also to add something, because Nikita, you were mentioning the collaboration with San Diego Fab Lab and with our dear friend there. In terms of expenses, something we haven't yet discussed. What we call School Fab Lab Makerspace has all the functionality as a big Fab Lab, except it's much cheaper, smaller, and easier to use because we intended to go into schools. So for example, in terms of hardware, to simplify, a school Fab Lab might cost $35,000 versus a regular school Fab Lab, what, 120, Nadia? More or less, 120,000. Roughly. Of course, it depends on how many people are going to come in. And if you have already some machines, etc. But this is a very important part because it makes a new initiative much more affordable, and I wanted really to stress that. Then what is important, of course, on top of that is the professional development of the people who are like Sam, you know, in interaction with students or members of the community, adults who are looking at being retrained, or to, you know, as someone put in the chat here, you know, COVID response, part of the COVID response initiative to promote, you know, new jobs. So this is a very important part. So it makes the investment size much more reduced.
And one other note, we don't sell hardware. We're basically sort of like community outreach. We provide the best list of hardware and consumable for you to buy. And if you want us to buy it, we will charge you 10% to buy it for you, but we rather you buy it and we don't deal with the procurement process. And one other component that we realized in that hardware list was that it's not just a machine. If you bring in 20 kids and you want to run a workshop, you need to have 20 kits of electronics so they can all work on and have a hands-on experience by themselves. So those are what we have changed in our model. And also we realize that if you want to run certain workshop, it is important to have something like a Google slide that is easily shareable to use, so you can modify and add it and start moving forward with that workshop. So you start developing your own set of already existing best practices going forward for each of these technology that is important.
I have a quick question. In all of your amazing expertise with all these Fab Labs across the world, you mentioned the Corsica site. Do you have any model that does shared, that sort of decentralizes a makerspace into, you know, different hubs have different capacities, but there's somehow a joined network? Do you have anything that's a model like that you've seen done?
The only model I know of that is actually functional and has a structure is a Fab Academy. It's a network of 60-70 nodes across the world that are sharing best practices in training and getting the next Fab Academy, which is part of a decentralized education, to get the people ready for developing their own project or learning different aspects of these type of technology. And they have this sort of the curriculum and how they go about covering this workshop, which is starting January and it goes until probably June or July. It's repeatable and they share and they connect. There are other unofficial ways of connecting and sharing, but there are many of those. But the Fab Academy is the only one I know that is really a structure and it's been going on for at least 5-6 years now.
Sorry, this is Sarah. I've been kind of putting things in the chat about funding. I believe that, and Sam answered my question. He said the only piece of equipment they're missing at the STEM Center is actually the vinyl cutter. I don't think the equipment is our issue here. I think it's getting people together across the islands and developing capacity. And then there were sort of the 4 barriers that were mentioned by Nikita that were very specific to the 3D printer operations, but could easily be barriers for some of the use of the other equipment. So it's really, in my understanding is it's capacity building that is sort of the huge gap, because we just don't have enough people here perhaps with the knowledge or the ability to share it widely. I'm throwing that question out to the rest of the community here to see if that's.
Well, and I can add in, I know, Nikita mentioned Derek Smith was the previous STEM director. And I'll just tell you flat out, he didn't have the time to really champion this kind of process.
Right, because I tried.
From the teacher side of it, and I'm sure that Kristen probably can speak to this as well. I'm a 1.2 FTE teacher in addition to being the career and technical education director. So I teach 6 classes a day. I don't have a prep period. And that's kind of for rural education. That's one of the tricks. We just don't have the FTE or the staffing of funding to put someone in charge of something like this and have a full-time STEM director, unlike you look at some of these places that really have, I'll use kind of the crown jewel in Washington State, the Tesla Academy in Bellevue. They have a staff of probably 6 or 7 people whose sole job is this kind of project initiative, supporting the CTE standards, and also babysitting and making sure that all the pieces are working together. How you accomplish that in a place where each island is its own separate school district is a huge question that I think will be something that does need to get answered. I mean, Kristen and I have exchanged emails. This is only my 4th year teaching in the island, and I think we've all had the greatest of intents to try to talk among the islands, but never have actually managed to accomplish that.
Yeah, I just want to echo that, Sam. Thank you. And I'd also just add that essentially any work in this realm for us as teachers is volunteering, because we are building something new. And it is a challenge. I'm not a full-time teacher. I'm a single mom, and I'm not only like teaching myself these skills in real time, but I'm also then thinking about how to use or kind of modify the program or specialize the program for what our scenario is on the ground. And I have Nikita on the island, which is this huge, incredible champion and resource that I feel like I haven't even gotten to carve out time for, but this, I feel way more motivated and space in my life this summer to do that and look forward to that. But I just want to echo what Sam's saying about the real life challenges in these small rural contexts. But also the whole reason why we're all here is because of how applicable and perfect this sort of context is for these small rural island contexts. So I'm really excited to be hearing everything that is here and look forward to further collaboration.
Simone and Nader, I just want to interject. How are you guys doing on time?
We're done. We're done. We really maybe want to just have two things. One, to share with you where we think we can be of value and service. Mm-hmm. And the second, really, if we have a few more minutes to brainstorm together where maybe our expertise can help into the thinking in the practical terms. In terms of our work, we, as you can see from our personal histories and work, we've been really committed to bringing complex cutting-edge technology into the hands of people who would otherwise be scared of it, including teachers. And we are very interested in working on projects that have an impact, and with the pandemic even more than ever, because it's touching even the US. We worked in 45 countries before. So what we want to say, what we would be, glad to offer is the capacity of doing this professional development, or it could be personal development, right? For retraining people for new jobs. And we can do that virtually. We showed you a small example here, but we have these 10 subjects, and each one has 3 levels of expertise from the basic initiation going forward. So that is something we can offer in your thinking. And if we would be happy now to think with you to see, what are you thinking? What are the options? You're looking at community centers, you're looking at another school, or you're looking at maybe specializing this island in a way. Are you looking at retraining people for what kind of job? Anyway, so we are a resource that's available, and really with a pure intention of creating goodness out of this chaos that is really destroying people's, earning, living, and security and all of that. So that's it for us. Unless Nader wants to add something.
I mean, what I really noticed in the last couple of years is the challenge of finding time. Most teachers that are in a forefront of bringing these new technology to the classroom really don't have much of the time, and they don't really have much of the resources available for them. And they're purely working overtime. And this been across the schools we are working with, I've been noticing that. And we believe that through the collaboration and through some of the best practices, we can reduce some of these initial starting point. And also, we understand that a lot of marketing goes into manufacture of machines and hardware producer trying to get into the same space. There is a lot of robotic program. There's a lot of noise in this space because everyone knows that this is where we need to focus on. And we believe that through understanding the best practices and sharing it with each other, we can really reduce this noise and also quickly understand what needs to be applied, what area we can put our energy in, and reduce some of these stress and overwork that is happening in this space.
So it seems to me one of the limitations, and I think people have brought this up before, is we've got the machines, we've got some people with a lot of know-how, and just finding ways to bring those together. So a lot of those machines are often in hands that are not necessarily available for community use, though. And so finding ones where people are willing to donate them, preferably without having to like work extra unpaid hours, would be great. And I think it's even beyond things like the 3D printers. Like I know somebody here who's a metal worker with all sorts of machinery to make very sophisticated metal parts. And we've had various other people like at the labs have been people who have been expertise in building microscopes going through and in fairly sophisticated machinery. So I think as Nikita mentioned, really figuring out how to connect those people and the machinery together. Like maybe a way to simply have a sign it like, I have this machine, send me your file, if that would work. And maybe the cash to buy the materials or donate something towards maintaining the machinery might be part of that.
I'm hoping with some of these awesome grant funding ideas that came through the chat might help. What I've noticed it needs is a dedicated paid staff person, because a lot of the people, Mickey, that you mentioned, I know a lot of them as well. We have phenomenal minds. I mean, we have some of the highest per capita education in anywhere in the United States here on the island, you know. So many people have master's degrees and PhDs and do specialized work, and most of them are retired. So we have a beautiful retiree population who like to volunteer, but they also like to go for several months to Mexico, to their other houses, or to blah, blah, blah. And so suddenly you have a volunteer population that when they're available, they're very excited, and then suddenly they're not available and they're gone, or a health crisis happens or a family member. And so what I've seen consistently is that we need one coordinator to help connect the dots and hold the space so that they can do the math. And it's mainly just all the email coordination. Nadir and Simone, I wonder, I'm thinking of places like my friends in Nairobi who do maker spaces. And I'm thinking of how, I don't know, maybe you know Trevor Snap and his work there. He's also an island guide, but he works a lot in Nairobi. And I'm thinking of how, you know, in a lot of these places there already are decentralized machines, but there's a central coordinator. Can you speak more about some of those models that we might adopt?
Well, at Schlumberger, we've had over 1,000 volunteers, employee volunteers, because I had built it with really empowering our engineers and non-engineers to go to schools and help. What I noticed is exactly what you said. The key functionalities had to be by dedicated staff, because otherwise everything collapses. So I think you're right by having one person, and I would have also consider, maybe having half a person as a backup, because sometimes people get very well trained and then they go for other jobs, so you don't want to end up with that vulnerability. And then organizing a way so that the people can sign in and creating different level of competencies and a timeline when they are available. So then the volunteers can actually chip in. And so from that, we can think with you based on our experience. And I think to what we are able to do is give basically the basic virtual learning on all these tools, right? The first 3 levels. The rest will be done completely on the island by dedicated staff and some of you expert. Plus, I understand from Mickey, you have very, very experienced people in one of these specific areas, but they don't have to be bored doing the first levels. The first levels can be done virtually. And then they come in when you start having people who are trained and motivated to go to the next level. So it has to be managed, yes.
Did you want to give a short overview of what the virtual, the apps that you guys use look like?
Thank you. You see, we are not really at all into a sales perspective. We're so much into like, what can make a difference? We forget to even talk about that. Yes. So all the classes, all the modules you saw are virtual workshops. Okay, so that's first. And they can be applied then on real world when machines are available. We created apps all you need is a smartphone or a tablet. So you can actually be in a virtual fab lab with all the machines working. You can choose a machine, let's say 3D printer, choose an object, choose the color, press, and see the machine printing it. And because it's an app, you can actually move inside the machine and see it. So that's for the fab lab thing. We also created a new app on what we call mixed reality, where schools can create virtual labs, for example, in chemistry, in other things, where we've been working with teachers, because, for example, not everybody can have access to the chemistry lab, even if we have one, a real, a brick and mortar one. And sometimes also the experiment need time lapse. So creating module, because people, when they are trained on the app, they can create their own content. If they need to, we can create 1 or 2 for them, but then ultimately people are trained to create their own content. So they can actually see time lapse or see things that are too small or too big that we have a hard time conceptualize. We're working with a teacher training center in Israel where they want to explain the solar system, for example. And you can imagine in biology or in, I loved yoga, so I'm a teacher certified yoga. I wish I had this app before, because when you can want to go to see the structure of the body, see the bones and the muscles, etc. With this app, you can go actually inside and turn and see how things are, how this whole system works. So yes, we have an app that allows to create virtual labs on any subject, as long as someone is trained to create the content, a teacher or an expert. Or sometimes we're asked to create 1 or 2 modules to show what's possible, and then people create their own content. Thank you, Mickey. I completely
That's okay. Do you have any screenshots or anything of what it looks like in the app? That like in one of the modules?
Nadia, you're mute.
We can send to everyone the modules, and I can also share something right now. I was trying to log into the meeting, but it doesn't let me do it on my iPad. So allow me to, just give me 1 second and I will share it with you if you can continue, and I will bring it up.
This is Marcy. I just wanted to mention that one of the things that caught our attention when we visited the makerspace in Hilo is they had some different types of equipment that was woodworking based. So trying to use local resources. And we've also been kind of following what's going on with hemp in manufacturing. And there's a whole line of insulated products that are being created with hemp that actually line the inside of a lot of BMWs right now. So I would also like us to think about not just plastic, but other types of resources that we can either grow or harvest here. And part of my thinking in that is when I fill out these USDA grants, they're often thinking about agriculture as food only. And I'm starting to think more about the fiber piece. There's a project in Marin that's a fiber shed organization, a group of people who are trying to figure out how to actually, you know, completely grow and make all their own clothing. So I think we have the potential here in our more closed environment to think about manufacturing that also includes natural materials. So it's just my plug.
I'm with you, Marcy. I'm at the, because I work at the very end of life, I'm really interested in how makerspaces can collaborate with local manufacturing. And as far as fibers are concerned, there is a group called Evermore, and they're in Seattle, and they have worked with a large process where they are sorting textiles and then taking apart their fibers and then rethreading them. So Marcy, let's connect on that, because we ship out on our tiny island of 2,400 people, full-time residents, we ship out 1,000 pounds a week of textiles. So that's, you know, like 52,000 pounds a year from a tiny island. So like the real cost benefit analysis of being able to do localized recycling streams that close the loop and that take things that are, you know, materials that would normally be landfilled or have a very long life and have a lot of carbon emissions to get shipped to, you know, halfway around the world to be recycled, I could see as a very viable option. But unfortunately, what we have found repeatedly is that we need mid-grade to industrial scale machines and a dedicated space and a dedicated staff in order to make those things possible. Because unfortunately, at the hobbyist level, you know, with that kind of money, you're just not going to get the end result that you need to make it viable.
I can share I can share my screen now. And so if you can find it online, these are pretty much a demo of the app. It's a augmented reality app similar to IKEA that you can put furniture in. We just put the fabrication machine into your space, and you can walk around it. They work and they function. You have an option of selecting the material, moving the machine around, and selecting what part you want to make, what color do you want to make it, and it will make it for you. This is on Apple Store. iOS is 99 cents. We had to put some price on it, otherwise we didn't get information on it at that time. And then there is a second version of this, which is a School Fab Lab educator app. You can also find that, and that one gives you more variety. You can download variety of objects from online and display it and demonstrate it. And we're now working on another version which allows us to really, you can create anything that you want and present it as a way that we call it the virtual learning, because you create a model, you share it with others, and then they have to go through that model and interact with it and find what you want them to find and add notation and so on and so forth. So we believe with, especially with the current pandemic, tools like getting online virtually with goggles. We also have a VR app. We call it FabLab VR. I can, all of those things are very easy to find if you like, Lab VR. And you can basically find them from, you can find video on these apps very easily on web. And they basically, these apps are designed. Yes. You still can hear me? Okay. These apps are designed for VR headset. This one we use HTC Vive, and variety of other headset can be used. And this was our first initiative. If you don't have a Fab Lab, how do you get someone to get into the Fab Lab and learn about it? And there are a variety of applications we are developing, but more than anything, I think it's just a matter of figuring out where the needs are and what can we do in this field, and that comes through collaboration. And we'd love to have you part of these development. We share a lot of these in our modules. How do you know, what is the new technology of AR and VR, and how you can get involved into these spaces. I think Unity have allowed a huge community to come together and bring a new way of connection through VR and AR. And I think the gaming industry is leading it, but beside the gaming industry, I think education will be the next level we can use these things.
Mixed reality would be a beautiful way to be able to collaborate inter-islands, you know, having a VR ability to have a mixed reality setup where we could be, for instance, you know, Lopez could be a VR headset or mixed reality kind of setting where they could be interacting with the machines that are on San Juan, and with a lot of, you know, the ability to do remote printing, as long as there's a person there who's going to make sure that the print doesn't go sideways. You know, we don't have to that's what I was really interested in for our models, that we don't have to replicate, you know, each island doesn't need to have a devoted maker space. You know, if they have a CNC cutter and laser cutters, and, you know, I know that there's a VR setup over on San Juan, how do we collaborate in a mixed reality setting in order to achieve some education and learning and perhaps manufacturing?
Are the apps Apple, or the augmented reality app, is that Apple only?
The augmented reality right now is only Apple. Then the reason for it is the Google Android platform, from a hardware perspective, is not very standard. It's like a PC world versus the Mac. You have so many manufacturing with different chip, and we have a very hard time supporting that Android with different product in the market. I think that will be changed very soon with the technology is improving exponentially. We right now have apps that run our apps. We have modules that run on Android, but we don't publicly want to support it because it's complicated. In Apple, when you get a device, you know it works or it doesn't work. If you have an older 6, for example, iPhone 6, it doesn't, but if you have a 7, it works. So it's much better regulated for us to start into that market. We have this AR station, which we recommend for most of the schools and most maker spaces. It's about 10 to 15 iPads. They're roughly about $250 per iPad. But with those iPads, you can fly the drone, you can program the drone, you can test variety of augmented reality app, and we basically use it as a way to take the lab on the go. So you basically take these 10 iPad and you go from one location to another location, you leave it for a week for them to experiment with it, and then you go to another. And our drone program is basically we use a drone that is not that expensive, it's safe for indoor use, and it runs with the iPad, so you can basically run a lot of workshop through the iPad and through the drone. Also, our AI is now moving into iPad because with the new iPad, which is a little bit more expensive, it's about $600 instead of $250. We have a depth sensor, and that allows us to really look at how AI sees the world, how we see very quickly the image and how the image is overlaid by the information, and then we can recognize so many objects and do so many things with it. And these are really very important from our perspective in showing how these technology really going to impact our life as we're going to go forward.
Yeah, I was just asking about Apple because it seems like that would be a sort of a limitation on how many people would be able to use them.
Correct. We probably in next 4 or 5 months we will be on Android with our new app. Actually, what we're trying to do is we're trying to be on Android and Apple and web, so you're not limited to any hardware, and that's the goal that we are striving for. So you can use the web VR to just basically, your experience is a little bit limited because you're not immersive or your camera is limited, but you still, if you have a normal computer, you can start use these apps.
We're well past the hour, so I don't want to keep people for too much longer. If you guys are happy to keep answering questions, I'm happy to keep things going for as long as people want. But I did want to thank everybody for coming, and thank you, Simone and Nader, in particular, for presenting, and Sarah for connecting us. But as I said, I'm happy to keep this Zoom meeting going as long as people are interested in chatting about this. And we'll send people invite to the Slack group if people want to use that as a platform to keep going.
Thank you so much, Simone and Nadir. I'd love to continue this conversation, and I have 10:30 appointments, so I have to run, but this is fantastic. And maybe there can be a follow-up time. I'd love to just share, I feel like I have some questions that I don't want to bother the whole workshop with. Or maybe other people would be interested in my questions. I don't know.
Thank you, Nikita.
Yeah.
I do have to go in 5 or 10 minutes because I have another call coming up, but I'd be more than happy to stay another 10 minutes.
I think we may have lost Nikita. So,
okay.
Yeah.
Very well.
It's present. Did anybody else have any other questions?
No, thanks for sharing all this. This is really exciting. I'm really looking forward to seeing and hearing more about this. I know there's enough people here in the islands that are just divergent enough to want to really just run with this tech and see what we can do about producing all of our own materials, particularly recyclable. If there's a way to take our waste stream of plastic materials and get it into a usable filament source, that would be, I mean, that at that point we're literally talking about alchemy. It's just fantastic. So I'm really excited to see all the momentum behind all this. Thank you guys very much.
Thank you.
Well, on that, I kind of wonder if making filament, maybe instead of thinking about making filament out of the waste plastic, maybe make the materials that you could use to mold the waste plastic into something else, because that might be a little more flexible in terms of the material properties that you have of the waste plastic. That
exactly, yeah, it's whatever we have a lot of, and turning it into something, a lot of that we don't want, and turning that into something we do want is huge. When whatever form that takes is awesome.
Very well.
We can't, I mean, we can't build a big manufacturing facility here really, but we certainly had, there's several examples of pretty sophisticated manufacturing that are small scale in the county. Like there's one that's making these, they're using CNC machines to make these sort of sophisticated devices used in construction of multi-story buildings. And then there's the one that's putting things on space telescopes, of course, and a few others. So I think like we may not be able to make something like the sort of traditional manufacturing program may not be very scalable for the islands, but something where you're using these higher tech methods could certainly has proven to be successful here.
And I think, you know, the materials that we do want to be able to work with too, as Nikita was saying, with textiles, with wood, those kind of things. But my focus, I think, moving out of this is probably to look around and see if there are sources of funding, or if we can get, if there are grants we can apply for. I mean, I just don't know, Mickey, you probably have a better sense of this, but like the community foundation, whether or not it's worth approaching them. I know they used to in the past say they would never fund people. They would fund programs, but they wouldn't fund staffing. So that's always the thing that we run up against in grants. You know, there's grants there for equipment, but not for the people to actually do the capacity building or run the equipment. So we have to do
a couple of grant options that we at the EDC have looked into, one of which we simply haven't had time to put the application in for, just because things came up, like a pandemic.
Yes.
That might be of interest. Yeah, I can talk with you about more after.
Okay, great. And I pinged Maury Foreman as well, who used to be at Washington State Department. You'll see an email in your inbox. Well, I just want to say thank you to, I don't have any further questions for these two. We probably need to let them go. They've been more than generous with their time. And, you know, thank you so much. It's been a dream of mine for about 4 years, right, Simone?
Right.
We finally got that done.
Yes. And we will see where it goes if there is enough energy and a commitment.
Yeah.
I think the time seems right, but let's see where it goes.
Yes.
And I think it would be good to come up with the subject matters that if we're getting back to the next discussion, we know what we're focusing on. If it's a recycling, if it's creating a network of manufacturer with makerspace and fab labs, or however you see on your side that is the most important and it's a place we can start, then maybe we can focus on that for the next meeting.
Super.
Very well. Thank you so much.
Thank you.
Yes, thank you guys so much for coming and for taking so much of your time to talk with us out here.
Bye.
Bye.
Bye-bye.